The new belt conveyor library in SimulationX enables OEMs as well as drive engineers to efficiently examine and control dynamic processes in belt conveyor systems and their drives, even before the system is constructed. In the following video, I'll give you a first impression of how that works. The dynamic simulation of a belt conveyor in SimulationX doesn't require complicated modeling. The existing libraries and the script-based model generator make it possible to automatically create a model. I'll begin with the model generator. After placement in the diagram view, some initial relevant parameters are needed, such as the input of the inclination profile. The inclination profile can be manually edited or loaded from an external table. Furthermore, the type of head station and tail station must also be selected. Now we start the generator, and the model is automatically created. The model includes the chosen components: tail station, multiple belt sections, the head station, a tension weight, and the load input. The parameters of each element are automatically referenced to the central parameter container and do not need to be manually distributed. In this element, we need to add technical parameters. On the tab Assembly, the parameter FF corresponds to the friction value from engineering norms. On the tab Belt section, you can find typical properties of the belt, such as width, modulus of elasticity, mass per unit length, and damping. On the tab Tail Station, the diameter and inertia of the bend pulley can be entered. There are various dynamic displays in the elements in order to give direct visual feedback. The yellow arrows give feedback about the inclination profile. The number of the belt sections is important for assigning parameters. Furthermore, the load of each section is displayed during the simulation, which we will see later. For the following simulation, the model was extended by a drivetrain, gearbox, and motor, a speed controller, and various control signals. Now we want to examine a startup process at full load. As can be seen, the model is initialized at full load. At a simulation time of 10 seconds, the startup process begins. After about 40 seconds, the belt conveyor has reached its nominal speed. Since so far no additional loading has taken place, the belt conveyor starts to unload. The belt tensile force in the upper strand is displayed below the model. These forces are displayed according to their position between 0 and 900 meters. On the left is the tensile force at the tail station, on the right, the drive pulley. The maximum and minimum tensile forces are displayed using an envelope. The results of the drivetrain are displayed in the next result window. The motor speed can be seen in the upper part, and the orange line is the set speed, and the blue line the measured speed. At startup, the controller in this example can't follow the set speed. Once it has reached the nominal speed, there's a small overshoot. Below that is the drive torque. Here you can directly read the maximum torque during startup. After that comes a phase of constant acceleration, and then the nominal operation point. SimulationX, as a system simulation tool, makes it possible to use the mechanical model of a belt conveyor for many other types of studies, such as virtual commissioning, analysis of energy efficiency, and the logistics control of complete process lines. Planning, commissioning, and optimization of belt conveyor system operation. Try for yourself the advantages of SimulationX and its belt conveyors library.